Hey guys, so my name is Shangat and in this video I'll solve the standard n queen problem with backtracking. So let's get started. Subscribe to the channel, press the bell icon so you never miss an update in future. So what is backtracking? Suppose you are given a problem and you have to find the solution such that the solutions are limited and the values that we can use for the solution are many. So basically what we'll do, we will start for every value and check if solution exists. If we can find the solution, then we got the solution. If we couldn't find the solution with this value, I'll try with next value till I die out with values or find a solution. As I get the solution, I'll show that this is my solution. If I couldn't find the solution, then I'll say that there is no solution that exists. So we can say that backtracking is all about hit and trial till we get the solution or we die out with the values. That's all. About n queen problem. Suppose you are given a chessboard and
Yeah, she's got some nice long hair, and you know that she's a bad chick. All the boys stare, can't help it, it's a habit. Clothes that she wears, short skirt and a jacket. I just wanna get her all alone on a mattress. I just wanna have it, I just gotta have it. Rumors all around say her body is fantastic. All natural, not a piece of fur is plastic. Head to her toes, yeah, they say that she's a latch. Yeah,
suppose here is a chessboard and we are given that we are to use n columns out of this and n rows out of this. We are given n by n chessboard and n queens. We are to place these n queens in the n by n chessboard such that none of the queen attack any of other queen. Let's move to the chessboard. So I have this old wooden chessboard and I'll use this chessboard to show you how can I place 4 queens in square of 4 so that none of them attack any of them. So instead of using these queens, I'll use these rooks because I have 4 of them, 2 black and 2 white. So let's start placing them. I'll consider only this part of board. So I'll place 1 queen in each column and I'll check all the previous queens such that none of them is attacking on the queen I'm placing right now. So let's start. In this first column I'll place this queen. So basically you have to consider this as queen. Now this queen has attack on these boxes and on these boxes, also in these. So coming to next queen, I can't place next queen here because that's an attack. Here that's an attack. Here it is safe. Now next queen in attack, in attack, in attack, in attack. So I can't place this here, so move this ahead. Now I can't place next queen here, attack. Yeah, here it is safe. Now the last queen I can't place here, that's an attack, 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 attack. So this is wrong and this has to be moved ahead. Now this is an attack, in attack, can't move ahead, so move ahead, in attack, in attack, in attack, safe. Safe. In attack, in attack, safe. So I got a solution. Now these 4 queens are placed such that none of them is attacking any of them, and this is not the only solution of this problem. The mirror image is also another solution of this problem. So let's create the mirror image. So I created the mirror image of my previous solution, and this is also doing the same thing. None of the queen is attacking any of other queens. Even these gloves are not so good to use. Damn. Because that stinks. So this was my chessboard with 4 columns and 4 rows, and all initialized with 0. By 0 I mean that all places are empty. So I'll start with column 0 and first row and check if that's an attack or not. If that is safe, because this is all empty, this is all empty, and this is also empty, so I'll place 1 queen here. So basically what I did, I checked if the place is safe, then put the queen and then solve next column. Okay, if I can solve this entirely, then I'll return true. If I couldn't solve this, then I'll return false. Okay, so I place first queen here. Now this place is an attack, this is an attack, this is safe, so let's place next queen here. Now next column, this is an attack, this is an attack, this attack, this attack. So move this ahead. Is this safe? Yes, it is. Not safe? Safe. Next column. Is this safe? No. 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 Is this safe? Yes, it is. No, 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 no. It's not safe. It's not safe. I can't move this ahead. So move this ahead. So is this safe? Yes, it is. Place queen. Is this safe? No. Safe? No. No. Safe. Next column. Safe? Yes. Next column. Safe? No. Safe? No. Safe. Next column. This place doesn't make sense. So if I exceed the number of columns, then I'll return true, because I completely filled up to this column, so I'm done with the problem. So if column is greater than or equal to n, n was 4 for this, then return true. Okay, basically I need 2 functions. First to find if the place is safe, second to solve the subproblem. Now to check if the place is safe, I need 3 parameters only. So let's write the boolean function that will return true if the place is safe and will return false if the place is not safe. So I'll have a board array. Okay, let's make it AR only. So I'll define this n as 4 for this problem. Okay, so int this array, int row, int column. Okay, so what this function will do, it will check you remember in that board, if I was checking if place is in attack, so I'll check all left blocks. So for I is from 0 to C, if AR, this row and ith column If that is equal to 1, then return false. Now after this, I'll go for all these diagonal blocks. So for I equals to row, j equals to column, if I am moving upwards, so I should not get before 0. So I is greater than equals to 0 and j is also greater than equals to 0 simultaneously. Otherwise it may be the case that one gets 0 and other do not. So that's not the case we should be considering. So I minus minus and j minus minus. So moving this diagonal, if AR IJ is equals to 1, then return false. Third case is I'll check these blocks. So for I equals to row, j equals to column, and because I is number of row, so I should be less than n, and simultaneously j, the number of column, should be greater than equals to 0 because I'm moving this diagonal. So this way number of rows is increasing but number of column is reducing. So this and I plus plus j minus minus. So if AR IJ is equals to 1, then return false. So return true. So if I have queen in the same column, then that's not safe. Same upper diagonal, that's not safe. Queen in lower diagonal, that's not safe. But if there is no such case, then that place is safe, so return true. Next function, solve function. So this function will have return type boolean because it will return true if I can find a solution and false if I can't find a solution. So boolean solve, it will have firstly the array, obviously, and that's of size n. A part of this, I am to have the column, in which column I am to place the next queen. Okay, so basically I remember the case when the queen were filled and I was supposed to place queen in the column that's not in our consideration. So if column is greater than or equal to n, this means I have filled this chessboard and now I am filling in the column out of this chessboard. So if column is greater than or equals to n, then return true. This means we have filled the chessboard and now over. Next case, if we are inside this, then what you have to do, you need not to place else here, because if this case run, then it will end this function here only, it will return the true, otherwise it will run this. So for all columns let's declare I and j first. I, j. So for I equals to 0, I is less than n, I plus plus. If in that particular given column, if that place is safe, so if I find safe what in this array ith row, and this column, if I find this safe, then it will return true. So if that's safe, then put 1 at this position, and after placing 1 here, I'll move to next column. So if I can solve for same array and next column, then what you have to do? Return true, because what next column will do? It will have a new column, and for all rows I'll check if the position is safe. If that's safe, place 1, solve sub problem, and in this way if I can solve all these sub problems. So if I can't solve the sub problem, what I'll do? Firstly, I'll put this to 0 again. So AR I column equals to 0 again, because this one is not helping me to get the solution. So where should I place this I in column? It should be placed outside of this, because if it can solve this, then it will just solve and return true, over. But if it could not solve this, then this statement will execute for this given I and this column, and it will store 0. So it will keep on solving till it get the solution. But if it could not get any solution till the end, so it will return false, that no solution exists. So at last it will return false, because if it get any solution, it will return true from there only by this statement. But if it couldn't find any solution, then it will return false from here at the end of this function. So let's move to the computer screen now. So here is n equals to 4, here is safe function, here is case 1 when it has a queen in the same row, here's the case when it has queen in upper diagonal, and here's the case when queen in a lower diagonal, and otherwise it will return true. Now for solve function, 2 parameters, if that's out of the number of columns, then return true. Otherwise, for all values of column, if that's safe, then put 1 and look for the sub problems. If we could solve the sub problems, then return true. If we couldn't find this solution, then put 0 again and backtrack. And ultimately, if we couldn't find any solution, then return false. Now in main function, declaration of board, initialization with 0, then if we could find the solution, then print it, otherwise print no solution found, and we are done. Let's run this. I just do not know why it shows this error. Okay, so here's our solution. Let's test this for some other value of n. So let's change this value to 9. Oops. Possibly solution. Yeah, it exists. So 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 queens and none of them is under attack. So this way we can use backtracking to find the solution of this problem. Okay, so this is how we solve the n queen problem using backtracking. If you enjoyed this video, give it a big thumbs up, subscribe to this channel for sure for more such videos. See you next time. Goodbye.